Hello world, Decentralized David here. We're going to make a quick inbox smart contract. So here we're going to set the pragma for solidity. We're going to set this to 0.422. This basically tells the solidity compiler what version of solidity we're going to be using. Next we're going to instantiate the contract, and we're just going to call this lowercase inbox. And next we're going to set our initial string variable. So we're going to make this a public string so that it's accessible by everyone. Next we're going to create the constructor. So the constructor is run upon the creation of the contract. And inside this we're going to create an initial message. So upon the creation of the contract we could put in a initial string message. And the next thing we're going to do is we're going to move down and we're going to create a function that will allow us to enable setting or updating the string inside this inbox contract. So this is meant to just be a really simple read and write string example. So here we will make this again public, and all we have to do here now is update the message equal to the new string. So super simple, just a few lines of code. Now let's move over and let's use the local JavaScript VM to deploy and test this really quickly. So you can see we've got some test accounts with either. Let's create this contract. So super simple, very fast inside the JavaScript test environment. You can see that there's no string in the message just yet. So here let's type in hello world. Let's set the string and then let's read. So we get hello world back. That works great. And then let's just make an update. You can see that works perfectly. So now let's jump over and let's do something a little more advanced. We're going to take our Solidity contract code that we just built, and we're going to wrap some Node.js code around this. And this time we're going to use basically a homebrew compile and deployment system instead of using what is traditionally Truffle today, which is kind of the go-to. You know, occasionally either Truffle's in Flux, or sometimes I find it's personally just really fun to actually know how to do something by hand or manually, or a little behind the scenes of how things are working. So first thing, I'm going to create this package JSON, and I'm going to cut and paste a few node dependencies in here that I need. And don't worry, I'll make this code available on GitHub. And I'm going to start this install process. This npm install will take a little bit of time. So while that's running, might as well just jump back over and do a couple more things. So let's create a contracts directory. And inside that contracts directory, let's make a inbox.sol. And we'll want to grab our Solidity smart contract code. So let's just jump back over and copy paste that. Well, and you can see I've got the Visual Studio syntax highlighter enabled. Makes it really helpful. And then we will want to create our compile JavaScript file. You can see the npm install is still chugging along. So let's just utilize this time and continue to work on our little JavaScript components here. It's amazing how much npm packages can save you time, and there's a lot of complexity in there. So here I'm just going to cut and paste the compile JavaScript, and let's just take a look at what we've got here. So we're going to pull in the path, the file system, and the solc, and then we're going to get the inbox path in the actual source file, and then we're going to pass that into our solc compile with the source variable telling it we've got one contract. And the name of the contract is inbox. And we're going to do a module.exports. That way we can use this up a level and some different testing pieces. So while we still have npm installed running, let's take a look at creating a little bit of a test using Mocha. And Mocha, if you're not familiar, is a JavaScript testing framework. It's very common, and we can make use of it inside of our environment here. So I'm going to grab a cert, Ganache CLI for running a local blockchain. We'll pull in Web3, and then here we've got to instantiate Web3 with our Ganache local provider. And then we'll pull in our interface and bytecode from the compile file that we just created. And this is going to be via the exports. And we'll just set up some basics, an account variable, an inbox variable. Then we'll just loop through a for each using async await syntax, because that's so much easier than promises. First thing we'll do is we'll grab the list of accounts that are available. Little dangling console.log there. And then the next thing we'll do is we'll pass in the interface via JSON parse and create that smart contract. This is using our local Ganache CLI. And then we'll set up some tests. We'll pass in hi. We'll check that that string is there. Then we'll update the initial set message with the string yo. So here, let's try to do a little compile. Whoops, what happened here? So let me take a look and see. Looks like I've put the compile file in the wrong directory. It's in the contracts. So let's move that up to the top level. And let's take a moment. Yes, that's there now. And now let's run our compile JavaScript. This will take a moment because this has to fire up the Sol-C compiler in the background. And that's basically what we were expecting, no error. So let's comment this out. And let's grab that first piece here with the Sol-C compile. And let's do a console log with that just to see what's happening there. And that is Sol-C compile. All right, let's save that and then jump over to our terminal. Run that once more. And it just takes a moment for the Sol-C compiler. And wow, here we go. We got a lot of output this time. And this is really exciting. So here we can see the bytecode of the contract. We can see the interface. We can see the function names, new message, set message. We can scroll down. We can see the opcodes, which basically are what you're paying the gas price for. And that references up to your bytecode again. So let's turn the console log off because we no longer need that component. And now let's run a test. You can see we've got test using the Mocha framework inside of our JSON package. No test files available. Let's take a look at what's going on here. So again, it looks like we've accidentally put the test folder directory inside the contract. So let's move that out and run npm test here. And this will definitely take a little bit longer because in addition to compiling the smart contract, it is going to deploy the smart contract onto our local private blockchain using the Ganache CLI. And great, looks like all the tests are passing. And you may or may not caught this. So I did have an additional typo here with the uppercase I in the inbox. So if we save that and then run npm test again, this will fail, saying that it cannot find the interface. Right, so just in case anyone saw that, you can see we have a lowercase I for our inbox. So let's save that, and then let's run the test once more. And now let's just take a look at the test here. So those dangling console logs, no one needs those. But basically we're gonna set an initial message. We're going to make sure that message is there. And then next we're gonna update the message. So looks like contract did deploy, that's great. We have our default message that is passing, and we can change the message. So very exciting, and it's really cool that we can do this with. Now that we have the compilation working, let's use this great service Infura. Instead of running our own local Ethereum Geth node, let's use this for deploying the smart contract code. You can see lots and lots of requests going through this per day, lots of data. It's a really great free service that allows you to read and write to the mainnet and testnet. You can see a lot of cool information, 8 million gas, the latest block number, the average gas price, 8 gwei. And then if we just take another look at the document, you can see how we can access all the different test networks, IPFS, and the mainnet. So if you sign up for free, they'll give you an API key. So if we jump back over, we'll want it to create a new JavaScript file for essentially running this deployment process using the Infura service with our API key. So let's create a new deploy JavaScript file. And let's move that out of our smart contracts to our root directory. And let's grab some code and just cut and paste it in here. Again, all this will be available on GitHub. So we're going to make use of the Truffle HD wallet provider. We'll create our Web3 instance. And here, the first line we're going to pass into the provider is our hardware brain wallet mnemonic. And then the next piece we will post in or paste in the API key that we need, so deployment key. Remove this dangling console log, and you can see we're going to create a function. That way we can utilize async await functions because they need to be inside of a function today to utilize those versus promises. And now let's just try to run this script. This will definitely take a little longer than even the test, because now we're going to actually be doing some API calls out over the internet, making sure that here we have the account that we're deploying from. This is very useful if we want to traverse this with some blockchain explorer, which probably will be fun to do. So let's take the wallet address and let's hop over back to our browser, and we'll want to use a service. Let's use there's several of them out there today, but let's use Etherscan. And they are hooked up into all the test nets and the mainnet. So let's just go to the Robson etherscan.io. Let's do our little Cloudflare sanity check to make sure we're not a malicious actor. And then let's just take that address and paste it in here. So you can see this might look like test address. If we click on this last block, we can see the contract was deployed, and here's the contract deployment. So very cool.